Hey everybody, it's Tony from Adafruit, and this is part 3 of the Raspberry Pi Internet Things series, where I'm building kind of an Internet of Things device with the Raspberry Pi, and so we've slowly evolved it over time. Started out as just a basic kind of load a web page, view the status of a switch, and change an LED, like turn it on and off. And then in part 2 that we did last week, we made it a little bit more dynamic, so we started using the server sent event stream to send data like the switch state down to the web page and made it look a little bit nicer using Twitter Bootstrap. So this week I was thinking let's kind of keep going, and at first I was thinking about maybe going into WebSockets and looking at two-way communication, and I think I'll do that in the next video. I'm thinking this will probably be like a 4-part series. For this video I was thinking let's add another sensor, something more interesting that we can measure with the Raspberry Pi, and then make the web page look a little more interesting by adding like a chart that will dynamically update and show a sensor reading over time. So I was thinking we could use like a DHT temperature and humidity sensor, and then build a little chart on the web page that updates over time, so you can see kind of neat dynamic data. So a good example of like a thing that has some sensors and some actuators that you can control over a web page for this. So let's kind of jump in and get started, and we'll see how things go. So let's see. Let's jump to the desktop and the kind of main view here. So so the hardware up here, so I'll do a demo first of just what we're going to build, and then we'll run through kind of building it all. So the hardware here, it looks similar, but things are a little bit different. I still have the LED, I still have a little switch where I'm just manually moving the input between low and high levels. And then this thing right here, this is an AM2302 temperature humidity sensor. It's a DHT series sensor, so these are really nice little low-cost temperature humidity sensors. I pretty much use them in every demo just because they're an interesting device. Like, they're cheap, they're easy to get, and they give you temperature, they give you humidity. They're not super accurate, but they're accurate enough for some interesting data. And this one is kind of nice. So normally these little sensors, you have to wire up and add a little resistor to them, but this one's kind of all in one. Like, it just has some wires connected to it, and you can just wire it directly to the Raspberry Pi. And I have a little Python library that you can use with the Raspberry Pi to read this sensor, because the sensor is a little bit interesting in that the way to read it, it's almost like NeoPixels, where they have a very certain signal with kind of strict timing constraints. And so the Linux kernel is actually not that good at reading that kind of a quick signal, and so you have to do a few kind of fancy things to make it work. But it's not too bad. It's pretty easy to get that sensor value. So okay, so let's do a little demo here of what we're going to end up with at the end. So I'll jump to the Raspberry Pi. So I'm just SSH'd into the Pi right here, and I'll run sudo python the main.py, which is kind of our web application. And so that's going to start up the debug server. And now I'm going to connect to it here, Raspberry Pi port 5000. And you can see, okay, things are a little bit different here. So this is, on the right here is the JavaScript Debug Console. Here, I'll just close that. So now you can see, okay, we've got this graph over here, and it's updating in real time, and it's showing us a couple things. Actually, it says temperature, but that's a little bug. It should actually say DHT sensor, because this is showing both the temperature and the humidity value. So if I blow on this DHT sensor, that'll increase the humidity and increase the temperature a little bit. So let me do that real fast. And then we should see, so okay, now things are starting to climb. So this bluish value right here, this is the percent of humidity. And this chart library that I'm using, it has a lot of options, so I didn't really set all the labels the way I should. I should probably have two different axes here. But you can see, okay, so humidity just jumped up to like 85%, and then it's slowly kind of falling down. And then temperature is down here, and it's in Celsius, so it's a little hard to read because it's so much smaller than the other values. But it's around, like 21, 22 degrees Celsius. So, and you can kind of see, unfortunately, as this animates, like, it doesn't really give you this hover over of the data values for the chart library. But there are all kinds of little things you can tweak with this to see the data values. But that's pretty cool. So it's like once a second, it's just pulling in a new temperature and humidity value from that DHT sensor. Now everything else still works the same. So I can click like LED on, and you see the LED turns on, LED off, so that's all the same. Nothing actually changed there. And then the switch is also updating too. So if I move this to a different input, then you see the switch turns on. And if I move this back to ground, then it'll turn off. So kind of cool, like, it's a little more dynamic, a little more interesting. Nice little chart display here. Like, you can imagine if you had something that had a few sensors, you could build a neat little dashboard with a chart for each of your sensors. And I'll show you this charting library that I'm using. A really nice little JavaScript charting library. It's called Chart.js. Has all kinds of different charts like bar graphs, pie graphs, stuff like that. And really easy to use, like just a few function calls you'll see to throw data at it. So that's what we want to do. We'll kind of dive in here and get started. So I wanted to start maybe with the DHT sensor. And so let's kind of get that code going. We'll modify our thing object. We'll just start with like our thing test code and check that we can read the DHT sensor. And then we'll start to send that data to the web page, and then we'll add the chart component to go from there. So let's see, I'm connected. I have a little SSH connection to my Pi, and it's mirroring my file system. So this on the left here is the file system on my Raspberry Pi. And you can see I've got a part 3 over here, and I've actually just copied part 2. And so this is all just the code for part 2. And we'll start here and start adding things to it. So let's see, let's start with, I'll stop the web server. And then I need to close this page because last time, remember I mentioned the web server for the Flask kind of test server doesn't really, it's not meant to do multi-threading, and I'm using a few threads, and so one of them kind of stays running while the web page is running, so I need to just manually close the web page. So okay, so I stopped everything. Now what we'll do as far as connecting up the DHT sensor, so we have a great little guide, and again I'll put in the description when this is up on YouTube links to all the different websites and things I mentioned here. So we have a nice little guide that shows you exactly how to wire up these sensors to the Raspberry Pi or other little small board computers. So you can see, and there are a few different types of sensors. So like the AM2302 is the one I'm using, but you could use like the DHT22 here, or even the DHT11, which is like even less accurate. I mean, it's not like it's way inaccurate, but it's it's not going to be as accurate as some of the other sensors. But hey, $5, what can you ask for that much? And they're pretty easy to wire up. So this is like a DHT22. You just need a little resistor here on the signal line to pull it up to a high level. And then you just connect that signal to an input on the Pi. Any digital input will work. And then you also need to power it with 3.3 volts and then connect it to ground also. So that's basically what I have wired up here with my AM2302. I have the signal line connected to pin 18 on the Pi, and then 3.3 volt power and ground connected. So check out this tutorial, it'll show you how to get going with it. Now the tutorial shows you this library that you can install, a little Python library to read these DHT sensors. And I'll just run through real fast what you need to do to install this library. So I've already done the install, but you basically just need to clone the repository directory. So clone this on the Pi. I've already cloned it, so I'm just going to delete this, and then we'll go into the directory and I'll show you the command that you want to run. So you go into the directory, the Python DHT directory, and then there's a setup.py file, and you need to run that to do the install. But before you do that, you have to install a few dependencies. So you want to apt-get install python-dev, python-smbus. And even though this doesn't use I2C, which is what the smbus library does, it's a dependency that the Python GPIO library I have has, so you kind of have to install it, unfortunately. But okay, so install that, and then also just Build Essential is a good one to install. Pretty much every Pi has this. Build Essential is the package that gives you the GCC compiler suite and like all the headers you need to compile code. So these are just kind of basic things to install. I've already got them all installed because I've installed this already, but you want to run that install, and then you want to run sudo python setup.py install inside of this directory with the DHT sensor. I've already run this, so I'm not going to run it, but it's as easy as that. It's just run those few commands and you'll get the software installed. Now there is some example code that we have in here, and the simple test is kind of the good one to run. Always a smart idea to when you add a new sensor, like test it in isolation. Don't go through adding all the code and then trying to debug it. Keep things simple. So okay, so in here, and I've modified this slightly, so I've changed it. Now it's using the AM2302. By default it uses the DHT22. You need to tell the library like what type of sensor you have, because it differs a little bit in how it reads the data. And then the pin I have this connected to is pin 18 for my sensor. And then all that this code will do is really just call this read retry function, and it gives it the sensor type and the pin, and then that's going to return back a humidity and a temperature value. And now the one big thing with this sensor, like I said before, it's kind of timing critical. So the Raspberry Pi has to read, like I think it's like an 80 nanosecond or so pulse, these kind of really fast little pulses. And normally the Pi can do that, but it is the Linux kernel. It's not a real-time operating system, so there could be something, if you're running like videos and really stressing the Pi, it might not run fast enough to read that signal very well. So you can actually get back like a null result or like a none result where you don't get back a humidity and a temperature value because basically, we couldn't read the sensor fast enough. And so this read retry function will actually try, multiple times. It'll just keep retrying until it can get a good sensor reading. And you can configure it. I think it says it retries like 15 times. So, it'll make a best effort, but at some point it just kind of gives up and won't give you a reading. But once it gives back a reading, then we'll just print it out. So we just print out the temperature and the humidity. So if I run this, I should be able to see the output. So sudo python simpletest.py, and you can see temperature 21.4 Celsius and 53.9% humidity. Now the one thing is you have to run this as root with sudo, and that's because this library, it uses memory mapped GPIO access on the Raspberry Pi, so it's not using sysfs, and it's doing that because it's trying to read a really fast signal, and sysfs has a lot of overhead, and so you get more reliable results if you talk directly to the Raspberry Pi's GPIO registers. But the trade-off is that when you're accessing the GPIO registers directly, you have to run as root because only that root account has access to that level of memory. Like right now in Raspbian, they've actually made some changes in ever since the Jessie release came out, where you can access GPIO without having to be root, but you have to do it through the sysfs interface. Or I think they even have like a little GPIO server or service or something that runs also. But ultimately, because this question comes up a lot with the DHT sensors, like, okay, how do I run without root? And unfortunately, you can't. You have to run as root because it's got to access the memory mapped GPIO registers. So, okay, cool. So the sensor works. We're getting a reading. So now let's integrate it into our code. And I was thinking, let's start with our thing.py class. And so this is the class that kind of has all the logic about talking to our hardware. So right now it knows how to read the switch input and how to set the LED. So I was thinking, let's add some new functions that talk to the DHT sensor and get like the readings and return back the temperature and the humidity for it. So let's just kind of dive in. And so as far as adding this library, I need to import the Adafruit DHT code. And here, again, maybe we'll look at the example code. I'll load this in here, that simple test, so you can see, this is just the example of how to use the sensor. So you've got to import the sensor. So we'll do that in our thing.py. And then let's add a little bit of configuration at the top. So let's do the DHT type. And this is the Adafruit DHT.am2302. So this you could set to what type of sensor, like the DHT11 or 22. And then let's configure the pin. So DHT pin equals 18. So that's the pin that I have the signal wire connected to. So, okay, so that's pretty easy. Now, okay, ultimately we need to call this read retry function to get back a temperature and a humidity value. So let's just do like a first initial little stab at it. Let's add a, how about a get temperature function. We'll say read the temperature from the DHT sensor and return it in degrees Celsius. And here let's just do, so let's copy out the code from the example and we'll read. So you get back both readings here basically. You get back humidity and temperature, but we only care about temperature, so I'll just return that result. And then let's give the configuration values that we used, so the DHT type and the DHT pin number. Okay, so that looks all good. And then let's just return back the temperature value here. So, pretty simple, pretty straightforward. And let's do the exact same thing for the humidity. So let's add that and then change this to get humidity and then read the humidity and return it as a percentage. So okay, that's easy. So same code here, and we'll return humidity. Oops, humidity, there we go. So okay, so that's pretty easy. And then to test this, I was thinking let's modify our thing test and maybe add in, so right now you run this, it'll grab the switch state and then it'll loop blinking the LED. So during this loop, let's read the temperature and the humidity and then print it out. So we'll say read the temp and humidity and print it out. So here let's do temp equals python dot get temperature, oops, and then humidity equals python dot get humidity, and then print these out. So we'll say temp, and then one little tip here. So this comes back, temperature is a floating point value. Python has really nice string formatting, and the default I think is something like 6 decimal places, or you get like these really ugly long kind of decimal place floating point values. You can control how many decimal points you want those. So with the string formatting that I'm using here, this 0 means basically the first parameter should be printed here. Then you can put a colon, and then here's where you can kind of define how you want to format this thing. And so for a floating point value, you can do like 0 point, and then how many digits you want after the decimal place, so like 2 digits, and then F. So this will say, okay, print out my floating point value, and you know, if it's less than 0, do like 0.2 decimal digits. You know, it'll always ensure that there are 2 decimal digits, and it'll round up if you know, if you have more data and it's higher precision, it'll round up to 2 decimal places there. So nice little tip. There are lots of cool ways that you can format stuff in Python. So, and it's handy that you can just, you know, do this by just learning that little formatting language. So okay, and then let's print out the humidity, and let's do the same thing with 2 decimal places. But here I actually want to use parameter 1, so I'm going to send 2 values into this, and then I want to call format, and let's pass in temp and humidity. So okay, so let's save that, and now let's run thing test. So let's go to my code here in part 3 in the web app. Okay, so sudo python thing test, and we should see, okay, so the LED is blinking, so that's good. And we see now it's printing out down here the temperature and the humidity. So it's reading it every second, the LED blinks, so we're reading the value there. And one thing to know about the sensor, it actually only updates data every 2 seconds. So you really should only call it once every 2 seconds. It doesn't hurt to call it more than that, but you're not going to probably get, you know, more accurate data necessarily. So okay, so that's cool. So that's working. Now the one big thing, and it's not really obvious here, you know, kind of what's going on, or you know, why this might be important. So you can see in my code here, you know, I added a get temperature function, get humidity function, and they're just directly calling this read retry. You know, like they're talking to the sensor and getting a new reading. But remember, we're building a web app, and web applications can have multiple users, and so you kind of have to think through, okay, you know, what happens if like 2 people are viewing this web page at the same time, and what if they both, you know, end up triggering a get temperature call in some way, so that, you know, they're at the very same time, or maybe one, you know, says get temperature and then the other one says get humidity, and they're both triggering this read retry function, you know, to call, because each of those users is going to have a request serviced in a separate thread. So as far as the kernel is concerned, you know, it's kind of happening at the same time, even though only one thread runs at a time. But then, you know, suddenly you're in this multi-threading world, and like we looked at before, you do have to think about serializing access to your hardware. So like worrying about, you know, if multiple things try to read the hardware, what happens if they happen at the exact same time? You know, are they going to overwrite each other and collide? And like, you know, what if the kernel lets like half of one user's read retry function run, and then it stops it halfway through and then starts the other user's read retry function, and then suddenly, you know, your hardware, there's only one thing. It doesn't have any concept of multi-threading. So if suddenly halfway through, you know, sending out a reply, it gets the Pi asking it again to send the data, it's going to get confused. So again, I want to think about like serializing access to this sensor and ensuring that, you know, that I don't let like multiple read retry calls happen at once. Now the simple way to do this would just be like I did with the switch and the lock and the LED down here, where I could just put everything inside of the lock that I have. So, you know, I could say, okay, I'm just going to add like a with lock to this and return the result. And I can do the same thing to my temperature. And then that way, the lock here is going to ensure that, you know, if two calls come in at the same time for get humidity, only one of them can take this lock at a time. And so one of them is going to get the lock. It's going to call read retry. It's going to get a result back, and it's going to return the result. Then it's going to give up the lock, and then the previous thread that was waiting for that lock is going to wake up and say, okay, now I can get the lock and I can read the sensor. So, you know, I've serialized access to that thing. That works. It's perfectly fine to do that. But I was thinking a little more, and like I said, this sensor, it only updates its data every 2 seconds. So, you know, really what I could do, I could create a new thread in the background and just have it run a loop that every 2 seconds will get a new sensor reading. It could save that sensor reading, you know, just inside of this class as some internal state. And then my get temperature and get humidity functions, they could just return back the last read result. So, you know, I'll have this little background thread that's just talking to my hardware, getting new data. It knows all about the sensor, and it knows, you know, I should only read it every 2 seconds to get the most recent results. So it can take care of all that. And then it simplifies my functions here in that they just need to return back the last read value for that. So let's jump in and kind of add that logic here. So let's see, I'll pull out the lock here. And it's not as hard as you think to use threads. So Python has a really nice threading library. So and like I mentioned before, the threading class in Python, way up at the top here, it's got, you know, really good documentation. So the thread object is what we want to use here. And the way to use a thread is, you know, you create a thread object, you have to point it at a function to call, which is this target value, and that can be anything. It's just a Python function. You can put any kind of code in there. That function could just run and end, in which case your thread's going to run and then it's going to stop and just be over. Or it could be like an infinite loop where it just, you know, runs forever and always does something. And then once you create the thread, you have to call the start function on it to actually kick it off and let it run. And then it's going to register it as a thread, and the PyKernel will give it a little slice of time periodically and let it run. You know, effectively it's running at the same time as all of your other code here. So that's one little thing. Now there's one little thing with threads too to worry about is the daemon or daemon mode. So this lets you say, you know, by default Python threads will actually block the whole program from exiting. So your program won't stop until every single thread stops. And in this case, I don't really want that, because this is just a background thread that's just going to constantly read my sensor. It's, you know, it's just reading data and just saving it. So that's not important enough to block stopping the whole program. Because things get complicated when you need threads to talk to each other. Like if I needed, you know, my main thread to tell this DHT sensor thread, okay, I'm shutting down, you know, you should stop too. Then you've got to worry about sending messages around between threads. And it's not hard. Like Python gives you a lot of cool primitives for that. But I don't need that. So I just want to keep it simple. And if I set this daemon mode on a thread, or daemon mode, then basically Python will say, okay, run this thread in the background. And if my main program quits, just kill the thread, you know, just stop it. Don't let it block the program from stopping. So I do want to set that, and so I'll show you how to do that. Okay, let's add this thread. So to add the thread, first of all, I need a main function for it to call. So I'm going to add a function to my my class here. So let's call this DHT update. And it's just a normal function on this object. You know, there's nothing special about it. We'll say this is the main function for DHT update thread to run. And it doesn't take any parameters. You could give it parameters, and in the thread dot, I think in the thread initializer, I want to say, let's see, where did that thing go? I think it's down here further. Yeah, in the thread object, you can actually pass in arguments that you want to pass to your thread function, your target function here, but I don't need to worry about it. But it's good to know that you can. So okay, in here I'm going to do an infinite loop. So just forever, I'm just going to run forever while true, and I want to read my sensor. So let's copy out this value here, and then I want to sleep for 2 seconds. So time.sleep 2 seconds. So just over and over, just every 2 seconds, going to grab a new reading. And I need to import the time library before I forget there. Okay. And then let's, instead of saving these as local variables, let's actually save this on the class itself. So like a class member. So we'll say self.humidity and self._temperature. So those will both be saved on the instance of the Pi thing. And just to be good, in my initializer, I should initialize these to, a starting value, because it takes a little while for the thread to get set up and start running. So until that thread starts running, I'm not going to actually have these values set unless I set them in the initializer here. So, let's do self.humidity equals, and we'll just set it to none, just, a null value here. And we'll do the same thing for temperature. So, okay, so I've initialized everything. Now let's create the thread. So let's create and start, DHT reading thread in the background. So we want to save this thread just so that, otherwise it might get garbage collected if I don't actually keep it somewhere. So we'll say DHT thread, and this equals a threading.thread object. Then I need to give it a target function, so this is what function it's going to call when it starts. And that I'm just going to give it the DHT update function that I created, so that's this function down here. And then that's all I need for that. Now I want to set that daemon or daemon mode, so I want to do self.dhtthread.daemon equals true. So this means it's a daemon thread. It can run in the background. It shouldn't block the program from exiting. And then I just need to start it. So self.dhtthread.start. And just for fun, let's put in, let's just print out here, main thread starting, just so we know when it starts running. Okay, so that looks good. So now to read the temperature, so in my main thread I'm saving them on the class, the PyThing class. So now I don't need to do really almost anything here. I just need to return the last result that we had. So just return self.temperature here. And same thing for humidity. So we'll just return self.humidity. So this is kind of nice now in that, lots of different users can be accessing my PyThing. They can be triggering get temperature and get humidity calls, but those won't necessarily be triggering calls against my hardware. It's only that little background thread that runs every 2 seconds. It'll talk to the sensor and read a new value, get the current state for it. So it's a good way to think of it in that, there's only one instance of this hardware, so I really only want like one bit of code to be talking to it, and that's what this little main background thread will do. So let's see here. Let's save this. Oh, I just noticed in the Twitch chat someone said line 31. Yep, misspelled. Thank you for picking that up. So it's a good reason to do live programming. That you've got pair programming with the internet basically here. So okay, so we save this. I think we're good to run the test again. So let's run the test. Now nothing should really change. If I did everything right, we should see that everything's kind of running. So like we're getting values back. This is cool. Like, it feels the same. Everything's running as normal. You can see we see where we printed out the main thread starting, and it kind of messed up the formatting a little bit. And that's because, this is a separate thread. It's running in the background at the same time, more or less, as your main program. So, my main program printed out the switch status, and then the kernel said, oh, I'm going to start this other thread. I'm going to give it a slice of time. And as soon as my thread started up, it printed out that it's starting. And it just so happened to print out before it printed the new line on this other line. And then the kernel, switched back to my main program. So again, just good demonstration that multi-threaded programming, you do need to be aware of like what things run at the same time here. So all kinds of little gotchas that you can have. So okay, so this is looking good. I'll cancel this. I'm going to remove this print statement just to keep it from being less noisy. So okay, so this is looking good. Now the other thing, I don't necessarily need to do this, but I was thinking, just to be consistent, I was going to throw reading the temperature and the humidity within the lock that I have. And the reason I'm doing this is that technically there kind of is a race condition here where, I have a background thread and it's setting temperature and humidity every 2 seconds. But you know, what kind of happens if like someone wants to read the temperature, and you know, they start reading the temperature, but then the kernel switches over and this thread, my update thread, runs, and then it starts to set the temperature as I'm reading it. Now it just so happens in Python 2.7 and maybe even 3.0, setting a variable value I believe is atomic. There are certain things in Python that can't be interrupted by threads, but that behavior might change. Like I think in like PyPy and other versions of Python, sometimes they don't have that guarantee, because you have that guarantee because Python has this whole global interpreter lock. So it's a weird thing that, you know, sometimes you can depend on that, but really to be truly correct here, to prevent any kind of a race condition where I'm trying to read a value that might be updated at the same time, you know, I actually want to take this lock, and I also want to take the lock when I set the value inside of here, so that, you know, this ensures that no one can read this value while it's being set. You know, if my background thread needs to update the value, it's going to take the lock and it's going to, you know, set the value. And if someone wants to read the temperature, then they're just going to have to wait for that lock to expire. Now you might also want to think about, you know, I only have one lock here and I'm using it for everything. So like reading the switch state. So that means like if I'm updating the temperature and the humidity and someone wants to read the switch state, even though they're totally separate hardware, they're both going to have to wait on the same lock. And I could create multiple locks. I could have a lock for each thing, but I'm going to keep it simple because this update thread only runs once every 2 seconds, you know, so there's a pretty low chance that things are going to be waiting for this thing to finish here. Okay, so I'll save this. And let's see. Oh, and I just noticed a question. Is this going to run as a service or as a cron tab? Yeah, I do have this set up as a service. If you go back to the first video, part 1, I showed there's a little systemd service you can run. So this kind of makes it run on boot. So it'll start up and it'll just immediately run your Python service. So systemd is great at being able to do stuff like that. So, you know, just make stuff run at boot. Okay, so I think we've got all the code here. And let me just check now that I added the locking that everything still runs. So yeah, it looks like everything's good here. So, okay, cool. So we've got, you know, basically our temperature data, and it's in our Py thing. So now let's start sending this data down to the web page. And to start with, I was just going to log it locally in the JavaScript console, you know, so we'll see the data come back, and then we'll add the graphing and the chart library to it. Okay, so let's jump in, and let's go to our main.py. So this is kind of our main application. And right now, the way we send the switch state is we use that server sent event format. And, you know, we just read the switch and we're just sending it back as this data value. And I was thinking, you know, let's extend this so that instead of having a switch endpoint, we have a thing endpoint, which is still using server sent events, but let's send back all of the current thing state. So the switch, the temperature, and the humidity, like all 3 of those values. And what we can do is we can actually just format them as a JSON object, so like a JavaScript object, and then our web page can just parse that JSON object and read out all the values that we get back. So I was thinking, let's change it from /switch to /thing, and just to be smart, we'll change this to the function. We'll call it read thing. So now let's, instead of read switch, let's call this read thing state. And we still want to do an infinite loop here. You know, it's going to run forever. As long as people have the server sent event connection open, it's going to send them data every second. And here now I need to change things. So ultimately I want to send back a dictionary, I was thinking, because JavaScript JSON objects are either like dictionaries, which are kind of like name value pair collections, or arrays, so like, you know, multiple sets of data. And it's really a dictionary that I have here because it's, you know, 3 bits of data, the switch, the temperature, the humidity that I want. So let's create a dictionary up here. We'll call it thing state. And let's add in some objects to this. So let's add the switch. And the value that we'll give it is just the result of calling that read switch function here. And then let's add in the temperature. And let's do pything.getTemperature, and then humidity, and we'll do pything.getHumidity. get humidity. So, okay, so that's easy. So now I have a dictionary object here, and it's got all my data. Now to send this as JSON, luckily Python has a great little JSON library. So it's in the standard library, so just import JSON. And to turn a Python object, like a dictionary, into JSON, you just use the json.dumps and give it thing state, give it the object that you want to dump here. Now you can't just throw a regular Python object at this. It has to be a dictionary like this because JSON doesn't know how to serialize like Python objects. It only knows how to serialize Python dictionaries and arrays because those things map directly to JavaScript dictionaries, or I think they're called objects in the JavaScript world, and arrays also. And then all the like basic types, things like numbers and strings, it knows how to serialize those too. So okay, so that's my state, and I'm going to send it back as the JSON formatted data. I still have to keep this data colon because that's the format for server sent events, and you still have to send the double end lines here to tell it, here's 1 bit of data. But everything else stays the same. And then read switch, I need to change this to read thing state because I changed the name of the function that I'm defining up here. So okay, so this is good. So this should now, instead of just sending the switch, it's going to send switch plus temperature plus humidity every second. So let's jump into our JavaScript code, and now we need to make a few tweaks to this because I've changed the endpoint. So like right now, it's creating the server sent event source, but it was looking for the switch endpoint, but now it's called thing. So I want to change how it generates the URL, and let's just change this to thing source, just so that it's smart because I could keep it the old name, but then over time I'm going to forget, and I might come back to this code months later and then realize, oh, is this just the switch state? But I see more than the switch state here. So it's always good to go through and make your code consistent with what it's actually doing. So right now it's calling update switch, and it's passing in the data that it gets back, but now it's getting back this whole JSON formatted object. So I was thinking, let's make a new function. So I'm going to keep the old update switch function because right now the way update switch works, it takes the switch state and then updates all of the web page UI. It'll change, it'll turn it from on to off, and it'll change the bootstrap formatting so it like highlights it red or highlights it black. So I like that logic. I want to keep all that logic, but I want to create a new function that will receive the switch state, and then it can call update switch once it figures out, okay, here's the switch state that I read from my thing state, and then it can also go and do something like update the humidity and the temperature state on the web page. So okay, so let's make a new function. Let's call this just update thing, and this should take in thing state, and so now it can actually just call update switch, and let's pass in thing state dot switch, and so this is going to assume that it gets passed in a thing state object, and so this object actually, it shouldn't be raw JSON. It should actually be parsed. The JSON should be parsed into a JavaScript object, and the way the JSON parsing will work, in that it'll create a JavaScript object with an attribute for each attribute in the object that I sent. So like in my dictionary here, I have a switch, temperature, and humidity attribute, and those will just be reflected in my JavaScript object. So I can just say thing state.switch. One nice thing I really like about JavaScript, in that this line right here, thing state.switch, is equivalent to this line also, reading switch from inside of a dictionary. Whereas in Python, if I had a thing state dictionary, this is the only way I can read the switch object or value from it. I have to use that kind of bracket notation. Whereas in JavaScript, you're perfectly fine to reference that attribute or that name value pair just with dot, the name of it. So that nice little syntactic sugar that I like about JavaScript there. So, okay, so I'm going to update the switch. Now, one little thing that's a gotcha that I noticed earlier. Right now, my update switch function is expecting to get a string, and it's doing this triple equals that will only be true if this is the 0 string value. But things have kind of changed in that instead of just sending a raw value, now I'm formatting it in JSON, and it just so happens when the web page parses the JSON and creates an object, it's not going to create, like, it's going to realize that, oh, this switch state is a number, and so I'm going to read this as a number and create a number, so it's not a string anymore. So I basically just need to change this to check against an actual numeric value instead of a string value here. So okay, so that's looking good. So I've got my update thing function, and now I want to call update thing. And then the one thing I need to do now is actually parse the JSON data and turn it into a JavaScript object. And the nice thing is, since I'm already using jQuery, it has a little parse JSON function. So I can just call the jQuery object.parseJSON and give it my data. So this e.data, it's a string, but it's a string with JSON inside of it. Then parse JSON is going to read that string and turn it into a JavaScript object. And then it's going to call update thing. And then update thing right now is just going to call update switch, but pass it the switch state from the thing state that was passed into it. And then let's just have it log the temperature. So let's do console.log, we'll say temp, let's do plus, so thing state dot temperature, and then let's log humidity as thing state dot humidity. So okay, so that's pretty straightforward. So now let's run the server and let's see what happens. And one big thing, so now I have to run the server as root with sudo, because I'm using the DHT sensor and it can only be read when you're root. So one little gotcha there. Like previously I was running it as non-root, but now I really do have to run it as root. So okay, so let's run the server, and it's running. So I didn't see anything crash, so that's good. And let's go to our web page now, and we should see things are working here. Actually, hang on a second. Let me make sure that we're doing the right web page. Okay, there we go. I think my browser had cached the older version for some reason, so this looks like we have part 2. So okay, so I think something failed. At least we're seeing something died here. But let's open the JavaScript console and let's start looking at what's going on. So let's go into the developer tools and see kind of what we see here. So okay, no, sorry, it didn't fail. Oh, this was actually because I reloaded the web page. The older instance had a server sent event connection open, and that died, and my thread died. And in the previous video I kind of explained what's going on here. So okay, it looks like this is working. Like we can see this is printing the temperature and the humidity every second. It's getting new value. Now the switch should still work, so I'm going to move this and we should see it update here. So yeah, just updated to on, and I'll move it back, and so now we're off. So okay, so that's cool. Like we're getting the data into our web page here. So now let's render it in some way. Let's add a chart here so we can actually visualize this data. And to do that, I was thinking let's use this nice library called chart.js. And there are a ton of JavaScript chart libraries. There's no perfect library. Like each one is kind of built in a different way. Like there's a really popular one called d3.js that a lot of people talk about and use, and it's a really neat library, but it's a little too low level in that you kind of have to build the chart yourself and add the labels yourself. I like this chart.js in that it's very few lines of code to get a chart that feels like what you might get with like Excel or a kind of standard data chart where you've got labels and you've got nice formatting and stuff like that. So let's use this library, and it's just distributed. It's a JavaScript file that you just need to include into your web page. So I've already downloaded it to my Raspberry Pi. It's in this chart.js master directory, and it's really just one file, this chart.min.js that I need. So what I need to do though, because I need my thing web server to have access to that, I want to add it to that static folder. So if you remember in the previous video, when we added Bootstrap, we had to add some static JavaScript and CSS files. So I've got this static JS folder here. So this is a great spot that I can just put my chart JavaScript in. So let's copy the chart min file here, and let's paste it into my static JS folder. So let's do paste there. So okay, so I've got my chart, and the chart.js website also is really nice in that it's got really nice documentation, good usage and examples and things. So okay, so I need to include my script here in my web page. So let's go back to my web page. So I'll just close that, and I don't need to see the static folder anymore. Okay, so up in my web page here, this is kind of where I'm loading all the scripts. So let's put a reference to it in. And remember, I need to reference it from the static folder in Flask, and the right way to do that is to use that URL function like we saw in the last video and tell it that, hey, I'm referencing static data. And then the file name here, go into the JS folder, and now I need chart.min.js. And so that matches the file that I have inside of here, the chart.min.js. And then make sure to close the script tag here. So okay, so that's going to load up the chart.js. And then let's see what else we need to do to use this library. So now to create a chart, you create a canvas object, and then you do a little bit of JavaScript to tell the chart.js that here's my canvas, turn it into a chart, and then it'll take care of rendering all the chart data and stuff inside of it. So okay, so let's copy out this canvas object. And I was thinking actually, where to render this chart. So right now in my web page, if I go to it, you can see I have like the switch state, the LED state, and then I was thinking let's put the chart as like a third column inside of here. And so, remember with the Bootstrap library that we were using, you can have up to 12 columns in a row. And so right now, my switch column takes up 4 units, my LED column takes up 4 units, so I have room for another 4 unit little column inside of this row. So let's just copy out this column, and let's add a new one. And here, let's call this DHT Sensor. And inside of here, I don't want the buttons. I want to put a canvas object. And let's actually copy out what the chart.js had. So let's use that. And we'll paste this in here. And then let's give this an ID of the DHT chart. So okay, so this will create a canvas. Now it's going to be blank, and actually I'll just we'll refresh the web page. You don't see anything yet. We just see DHT Sensor. So okay, so let's look at the docs again. So now to create this, they tell you 2 ways. If you're not using jQuery, you can use this method up here. But I'm actually using jQuery, so I'm going to copy out the second method that they mention here. And so let's start putting this into our JavaScript code here. So let's go into our index. So let's set up the chart maybe before we do a lot of the other initializations. So we'll put it up here. Okay, so now I need to tell jQuery the name of my chart. So this is that ID value that I set up here. So I want to give it the DHT chart. It's going to call get, and then it's going to call get context. I think this is from what I understand, I think it's just going in to that canvas object and getting like its 2D rendering object. Because the chart library needs that. You can't just point the chart library at the raw DHT chart element. It needs to be some of the context inside of it. So okay, so we're doing that. Let's call this DHT chart, and let's save that, and let's maybe look a little bit more. So okay, so this will just kind of create a new blank chart, but there are lots of different chart types that they have. So like you can see, they have a line chart, and I really like the way that this library renders, like, real nice, smooth, charts. And you can actually control, so like this is actually doing a Bezier curve to, make all the data points look nice and smooth. But you could just have raw lines, that just go straight to your new data points. One cool thing about this library is that it has tons of configuration. So you can kind of scroll through, like these are all the different options you have for this chart. Just how it renders thing, every little bit of color you can change, so really nice. But it's also got bar charts, so real cool, nice little charts. Radar chart, which is, you don't see these too often, but it's kind of neat to have that option. The polar charts, which I don't think I've ever used one of these, but hey, it's there. And then I liked the pie and the donut charts. These are kind of nice, like real simple flat shaded things. So okay, the line chart is what I was thinking we would use, and they kind of show here that to create a line chart, you create a chart object, and then you call this .line function, and you give it some data which describes kind of the data that's in your chart. And so let's just kind of steal their example code here. So let's just grab this and put it into our code, and then let's grab their example here and put it into our code. And all right, so we'll paste that in, and let's fix the formatting a little bit. So just kind of move that over. So okay, so we've got their data. Now I need to change things a little bit. So I'm actually going to, let's copy out this line here, and then let's change it so that we pass in the chart. So we'll create the chart and we'll call this line function immediately. And the data that we want to use is down here. But what I'm going to do, because I'm not going to set any options here, I'm actually just going to pass the data in directly like this, so that I don't need to create a separate data object. I'm just passing it in, creating the object on the fly here. And so, okay, so this describes the chart. So you can kind of see how this thing works, in that this chart has two data sets, so there are two lines inside of here. One of them is called my first one, my second one. This data attribute is actually the raw data that's rendered here, so it's just some like random values. And you can see they've got all the nice configuration to change all the colors and things. And then the labels are the x-axis, like the bottom axis, and what are the values here. So you can see there are 7 values down here, and so there's 7 values down here also. So let's just save this, and in theory I think this is all that I need. I don't think I need to call anything else on this chart. So let's reload our web page, and we should see. So okay, cool, there's our chart. Like, this is basically the example chart that they had here. So there's all the raw data that's available. So that's kind of cool. I think we can use this as a base to add our temperature and our humidity data. So let's tweak the chart a little bit then. So I'm going to pull out all of the data values that they're setting here. So let's just delete all the labels, and let's delete the data. So like, this is basically going to be an empty chart to start with. Now I still want two data sets because I have temperature and humidity, so I'm going to render them as 2 different lines. But let's change the label here. So let's do temperature, and let's put in Celsius, and then let's do humidity as a percentage down here. So okay, so that's cool. So, and if I re-render this, we should see the chart actually should be blank. So yep, it's blank. There's really nothing to render yet. Okay, so now let's look at how do we actually dynamically add data to this chart. And it turns out that Chart.js has thought of that problem already, and it's really simple and easy to use. So if you scroll down for the line chart, they just have a couple functions. There's add data, which will add a new set of data points at the end of the chart, and then remove data, which will remove the oldest data point, like the first data point here. So and you can actually go in and like reset all the data and call this update function to re-render it. But this add data is like a simple little helper that you can use instead of that. So the way this works, you call add data and you pass in an array, and that array has the new value for each of the data sets. So because in their example and in our example here too, we have 2 data sets, the temperature and the humidity. So you need to pass an array with 2 values, and the first value will be your first data set value, so that's temperature, and the next one will be the next data set, humidity. And then you need to also give it a label. So this is just what's going to print on the bottom, the x-axis there. So okay, so let's do that. Let's put in a call. So we've got our update thing function where we're logging to our console the temperature and the humidity. So let's call that add data function and go from there. So I'm gonna need the chart. So I'm gonna call my dht chart dot add data, and I have to pass an array with the 2 values, and I want to make sure I get the order right. So it's temperature first. So let's do thing state dot temperature. And then humidity, thing state dot humidity. Humidity. There we go. Yeah, there we go. So humidity, and then I need to pass in the label. So for the label for this, since this is going to update every second, I was thinking let's just show the current time. And it turns out JavaScript has a lot of ways to render the time. The way that I think makes the most sense is let's just render kind of my local time. Like you could render like an an ISO date time string that's this long string that has like the time zone and all that stuff. But I'm viewing the page. I probably want to see it in my local time. So the way to do that, you create a new date object, and then you call the toLocale time string function. So it's kind of a weird function. The one web page here. So look up MDN date, and this is the date class in JavaScript from the Mozilla Developer Network. This has all the different functions. So you can see the date class has a ton of different functions, like lots of ways you can render the date. But this one makes sense, and it's easy enough to do this. So okay, so let's save that. So now we should see, when I refresh the page, some data coming in. So let's refresh it, and this is cool. You can see like the data comes in, and the awesome thing, like this chart.js, it knows how to animate the data. Let's see, I'll close the console. So you can see as new data points come in, they're animating. So if I blow on the sensor, we'll see these things jump up. And I didn't have to write any of that animation code because honestly I couldn't if I wanted to. My limits for JavaScript are like calling JavaScript libraries. As far as like animating things, that's just a whole world that I don't want to get into. But now you're kind of noticing, okay, we're adding data, but like at some point we're just going to keep jamming so much data in here, the chart's going to be unreadable. And it's a cool thing too. You can kind of notice like this library is making a best effort at trying to render everything. So it like, tilted my labels at some point, and I don't even know what's going to happen once we get enough data in here. Maybe at some point it just gives up. But okay, so let's limit the data. Like let's only keep the last 40 measurements, because I think those will kind of fit on the page. So really easy way to do that. So remember, you can add data, but you can also remove data. They have the remove data function, which will pull off the very first element, which would be the oldest element. And that's exactly what I want. So what I was thinking, let's actually add in a check here. And I want to see, do I have 40 or more data elements already? And if I do, then I want to remove the first one because, I just added one at the end. And so the way to do this, unfortunately, there's no nice little helper to get how many data items you have in the chart library, but you can just reference it. So it's this datasets.points array will have it. So if I go in here and if I check my DHT chart datasets 0, so this is actually referencing the first data set, the temperature data set up here, and it's actually going to look at the point data that it has inside of here. And so this is an array, and so I can use the length attribute in JavaScript. So if that's greater than 40, then let's do some logic. Let's call it DHT chart dot remove data. And I think I got that right. Let's just look at their call. Yeah, so remove data. So it's going to remove the first value from the chart. And this should be all that I really need to do. So let's refresh the page and see what happens. So you can see like, okay, this is a mess. It's cool that you can see all the data, but it's maybe too much for this web page. So let's refresh. And so, okay, cool. So now we're getting the data rendered. And again, you can kind of see like, okay, the labels all fit here, and then it's going to kind of slowly move things around. But we should see after it gets 40 data points, it stops, and it'll just, it'll drop the oldest data point basically once it fills up the data here. And kind of as we wait here, we can see everything is still working as is. Like the LED, I click that, the LED turns on, turns off. The switch, I can change that. I move that to on, move that to off. So, we haven't broken anything. That's good. And really, the only change we've made is that we've added the new data here to the server sent event. So, okay, I think did I get something wrong? It looks like it's adding a bunch of things here. So let's open up the JavaScript console again, because I might have messed something up. Let's see if there's like any errors or messages that we see here. No, I don't see any errors. Okay, so I must have gotten something wrong. Let's look in here and see what I got wrong. If the chart dataset 0 points.length is greater than 40, then it should remove the data. So I don't know why that's not working. Maybe the web page didn't reload. It might have been cached. So let's close this. And let's reopen. And now let's see. So we'll wait a second here. We can also look, we can cheat and see, since I did this ahead of time, make sure that I got it right. So let's look at the example. Let's go to our template here, and we should see the exact same code in here. So yeah, remove data we're calling. So that looks good. Oh, I guess I was using 20 before. I'm using 40 now. So maybe we want to limit it to 20, because yeah, 40 is probably not going to fit. So let's go back to our code and change it back to limit it to 20. So okay, let's do 20. Now let's reload the page. Okay, so do that, and now hopefully things are working here. So you know, this is pretty cool though, and I could change this chart type. I could make this, you know, a bar graph. I could have multiple charts. Like right now, this chart is a little hard to read because, you know, I have two sets of data. I have the temperature and the humidity. Now they both kind of fit on the axis on the left here, but in reality, you know, I probably want like a separate chart just for the temperature so that you can see exactly what that is. It can have its own y-axis, and then, you know, have a chart for the humidity here also. But it's, you know, it's not hard to do that. It's just add another chart and, you know, just basically clone all the JavaScript code I had before. But instead of having two data sets, just have one inside of there. Now it looks like it's working. So you can kind of see here, you know, new data comes in, old data gets kicked off the end there. And it's just enough that fits, you know, pretty well without being too cluttered. So if I blow on the sensor, then we'll see this jump up. And, you know, everything looks like it's working like it should. We can turn the LED on, turn the LED off, you know, see the switch status again. So everything seems like it's, oops, let me move that over. So that's on, and then move that back, and now it's off. So, you know, I think everything's working. I think we built what we set out to do in this stream is, you know, just to kind of summarize it. So we extended our server sent events, and now they're sending the switch state, the DHT temperature and humidity sensor state. So, you know, there's one server sent event endpoint that just every second fires off the current state of my Pi thing. We added that DHT sensor, and we thought a little bit about, you know, this is multi-threaded. We're having potentially multiple things happening at once. So, you know, we built a little background thread to talk to our sensor, get new sensor readings, and then our web page can just read those sensor readings really easily. And then we just integrated a nice little chart library that, you know, really with like maybe 10 or 15 lines of code lets you render a nice little chart like this. And so that's pretty cool. Like we've got a neat little dynamic web page here that's rendering the state of our thing. So that's, I think, mission accomplished on this one. This one looks pretty cool. So if folks have any questions, maybe throw them into the chat here, and we'll see if we can answer them. And yeah, so I was thinking the next stream, so I'll do another stream on Friday next week to do like a part 4 in this series. And I'm thinking maybe I'll wrap it up at part 4. Oops, let me turn off the other shots. Kind of a funky view. There we go. So yeah, so I was thinking part 4, maybe I'll come back and let's look at using WebSockets as a way to communicate from the web page to the server and vice versa like that. So it's just a different way. It's kind of like using our server sent events, but, you know, with more functionality there. And we can kind of see, you know, what are some trade-offs and how difficult it is to use that. So, okay, I don't see any questions, so I think I'll wrap up the stream then here. So thanks a lot for watching. Subscribe to youtube.com/Adafruit. You can see this and all kinds of other fun videos. There's a fun little video I put out today also, the smart toilet light. So check out the Adafruit website and check your calendar because you know what day it is. But it is a real project, and it's actually kind of funny. So yeah, check out YouTube, subscribe there. Check out twitch.tv/Adafruit, subscribe. You can watch the live streams that I do there. Then almost every day we have different live streams. So there's Desk of Lady Ada, Noam Pedro of Layer by Layer. So all kinds of cool content that we've got coming. You know, we're definitely not slowing down. There's all kinds of things in the pipeline. So thanks for watching. I'll see everyone Monday. I'm going to do another live stream on some Raspberry Pi stuff. So this week, Monday, I looked at using Amazon's code to use the Alexa voice service, like to turn your Raspberry Pi into an Amazon Echo effectively. This Monday, I was thinking I'm going to look at another version of that code. Someone wrote a Python version that's a lot simpler, probably a lot easier to set up because the Amazon one has, it's a little wacky. It's Java, so it's a little crazy. So thanks a lot for watching, and I'll see everyone in a few days. And in a week from now, we'll pick up part 4 of the Raspberry Pi Internet Thing project. So thanks a lot, and I'll see everyone.